Welcome friends. Up to now the 3 units had been taken by my friends, and let me take the fourth unit called circuit emulators. And the introduction of this unit is circuit emulator is used to debug the software of an embedded system. It operates by using a processor with the additional ability to support the debugging operations as well as to carry out the main functions of the system, particularly for old systems. With the limited process, it is usually involved replacing the processor temporarily with a hardware emulator, a more powerful although more expensive version. And up to now we have discussed about the introduction, and the introduction is clearly says that the circuit emulators is the process of debugging the software system. And if it is an older version, maybe there is a chance of replacing the debugging, because there is no alternate of clearing it, because it is as it is an old version, we cannot upload it, we cannot clear the bugs which is found. So what we have to do, it means, but with the limited process we have to change the system. And also if we are doing that, it is a more powerful and expensive version. And in history, it burned out the process, which is mainly internal signal, brought out the process of debugging. These signals provide the information about the state of process, and it states that it clearly shows that the information which is we are getting from the software is this circuit emulators, and this is a process. And let me go into the topic. The first topic of circuit emulators is real-time trace, and the name itself shows that tracing. If any bugging is there, if any problem is there, or if any errors is there, and there is RRT will find it and clear it by using the new software called real-time trace, and it may find the errors, and also it may clear the errors. And here is the data which had been given. The real-time trace is a more powerful technique that can help the developers find the most difficulty bugs and can vastly reduce the amount of time spent debugging an application. When they are checking an application, this RRT may clearly and very fastly shows that bugs. If it is a big or small, whatever it may be, if it is vast or small, it clearly shows that it clearly finds the bugs in an application, and also it reduces the time. The debugging is probably the part of development, whereas most time is spent for many reasons. It is a part of development process that usually can be planned the least, given the disadvantages inherent with the printf and runtime debugging techniques. And it clearly states that the inherent of the disadvantages is from printf and runtime debugging techniques. And it's clearly if it is in a software or if it is in an application, it's clearly clear the debugs which is found if it is more difficult or big. And those tools are insufficient for the finding the most challenges bugs. With only these tools at the developer's disposal, the debugging efforts could be the weeks or the development schedule. This is where the real-time trace debugging can be used great advantage. And this can be used as a great advantage because we can find the biggest errors in it, and we can clearly debug the probability of problems. Sequence program counter PC values, and these are the techniques which we are going to use for the RRT. It is sequence of program counter values, memory reads or writes associated data values, register read or writes. The RRT block consumes space on the SoC. Although modern process technologies may this less important, it is still a consideration. It is an important select an RRT technology that is built time scalable, so it can configure to match the nature of typical use case of the SoC. The RRT is used for the typical case of the SoC, and it can build a time schedule for this technology. The RRT logic block consumes extra power. It's therefore the important to choose an RRT solution that allows the RRT block to get it off when it is not used. Here it's mentioned that when it is not using of RRT, it may close automatically. An external debug probe is often needed. Therefore, choosing a solution that works with an efficient cost-effective debug probe is important. It's clearly mentioned that when RRT is working, we need an external debug probe. Without that, we cannot do anything. And the efficient and cost-effective debug probe is important. we need a less cost and debug probe is important. And this is about our topic of RTT. Thank you. And next classes will be uploaded later.